Welcome back. So we have solved these two questions. Now I will be doing this third question, longest substring without repeating characters, which is a medium questions. So let's proceed with this. Okay, so let's go for full screen here and full screen here as well. And there's some issue with now it goes for full screen. So the question is, let's first read the question. So we will also have a timer for ourselves for targeting. I'm targeting for a timer of 35 to 40 minutes. Let's say 40 minutes because I will be 45 minutes. Let's say 40 minutes. I will be explaining, try to explain at the same time. So, okay. So, given a string, find the length of the longest substring without repeating characters. So, this is a single line, just a single line description. So, we need to find the substring. What do you mean by substring? So, let's clarify that first. So what a substring is, suppose I have a string a, b, c, d, e, f, e, d, f, and suppose a. So the substring will be continuous. Basically substring and subsequences are the two things. So now substring will be continuous and subsequences are not continuous. So in this case abc is a substring, and bcd is also substring, and defaa is also substring. But if we talk about subsequences, we can have a. So in subsequences, the order in which the character appears are in the same order which they are present in the string. But basically in substring you can skip characters. So suppose we have a, b, c, d, e, f, a. So now what you can do is you can pick a, then you can skip b, skip c, then you can have d. So a, d, then you can have a, d, e, f, a. Basically, so that's a subsequence. So here we are asked to find a substring. So there will be no character skipped between the two pointers. So if I have one pointer here and one pointer at the last a, so then this whole is the substring. Okay, there are substrings. If you want to know, there are total n square substrings. So if you can search a number of substrings and subsequences in n string, so again a number of strings and subsequences in a string. So the subsequences are 2 to the power n, 2 to the power n. It's exponential basically. So 2 to the power n, yes, 2 to, because for each of them we have two decisions to make. So let's number of there's so many substrings, number of substrings, how many substrings in a string, then how many sequences in a string. Let's check that. So nope. If you have this number of substrings in a string, and that will be, this is the formula, n into n plus 1 by 2. Okay, so given a string, if you want to know how many number of substrings, so substrings are, so this is same as for arrays. In case of array you have subarray and subset, so the same rule applies there, subarrays and subset. So in case of substring and subarray, the number of substring and subarray is n into n plus 1 by 2. Okay, and the number of sequences or subsets of an array is basically 2 to the power n. So you could see here, see, subsets are 2 to the power n. Order does not matter in the sets. So subsets and subsequences, so see, both are this, and in the case of substrings 2 to the n into n plus 2, sorry, n into n plus 1 by 2. Okay, so this is correct. Now let's do the question. Now you can also think why it would be like this. So in case of subsequences, if you talk about subsequences, so for each of the element in the string, So let's take the string as A, B, C, D. So each of them has one two choices. So if we are making a subsequence out of this string, then we can choose to have a character in our subsequences, or choose to not have a character in the subsequence. So for each we have two choices. So totally there are four or n a number of characters. So the two choices, there are two choices, so it's total number of subsequences are 2 to the power n. Okay, this is how uh, then if you talk about substrings, so why substrings are, why there are n into n plus 1 by 2. So you can simply check, like if you have to make a substring, how would you make? You pick a, then you will go through each of the each of the elements or each of the characters in the string. So a, then you take b as the endpoint, then you take c as the endpoint, then you take d as the endpoint. So if you traverse only first time, then you have n substrings. Okay, then you take b as the first starting point, then you travel to the other half of the array. So in that sense, then you, so first you see, first you will have n substrings, then in this next second iteration you will have n minus 1, then you will have n minus 2, then you will have n minus 3, and it keep on going till you have got 1, which is basically sum of 1 to n. If you see this order, it's basically adding 1 from n, which is sum of n natural numbers, which is n into n plus 1 by 2. So that is the reason. Now we are here to find the substrings. Okay, so this is the example, and now the main part is this is without repeating the characters. Okay, so this is the substring that, for example, here it is. Let's make a so that I don't have to again put this. So if this is the substring a b c a, b c b b, then you need to find a substring which has the longest length of the substring, which does not have a repeated character. So okay, when we see first, if we choose a to be the a, so let me write here. Okay, so if I write a b c a b c b b, so if I choose to start from a, then I can take a. If I choose to start from a, then I go from here, so I can include b as not repeated, then I can include c as well, then I go to a, I reach a, so now I cannot have a. So at a my substring would break, so I would have a b c. Okay, this is one substring that I can have. If I then again choose from start from b, this b, second b. Okay, so if I start from b, then I can have b, c, then a as well, then again I cannot have b because it breaks on b, b is repeated, so I cannot have that. So and if I go from c, though I can c, then I can have a, then I can have b, then again I cannot have c. So it's very pattern, the pattern is very formatted. So if I were to start from c, this c, I can go to c, a and b, I cannot go to c again. Okay, then let's start from the next a. So I can have a, then I can have b, I can have c, then I cannot have b again because I already have b. So a b c is the only pattern. And if I start with the second, this b, of this b, then I can have b c, which is will be smaller as I cannot have this b. And if I start with c, then I can have c and b, I cannot have this b. And if I start with this b, I can have only one b. Okay, so you can see the maximum length is 3, which can be initial ABC, then BCA, CAB, ABC again. So these are the ones which are maximum. So let's find a brute force solution for now. So what I can think of a brute force solution is basically I would have some kind of counter, which will be, because we are not caring about what is the that longest string. Basically we just want the, okay, so you want that is this on this should be remembered. So input is a string and output is integer. Basically we just need to find the length of the string. Okay, so we just need the length. We do not care about what that string is actually. So we can just have a some kind of global variable, means a counter. So in that we can just update if, and as soon as we found any substring which is greater than what we already have found. Okay, so we will have a this variable, and then we will first have, so one is basically we can, the brute force solution is basically we can just go through uh, all these substrings, okay, which will be having n into n plus 1 by 2 substrings, which is n square algorithm. So we can go through all the substrings, and in each of the substrings we can check if there is duplicacy or not, which can be doable, which is doable, but then it makes that algorithm see. Now getting going through all the substring will be n square, and if I do in that n square, all of those n square, I do n operation of n operation as well, so it becomes n cube algorithm, unless until I store these n square elements. So that can become of n cube, which we don't want. So okay, what we can do is we can I'm thinking of having, so this we have a string, so now these string will be having 26 characters only. These are all small letter strings, or even if they are big capital letters, then also their total characters will be 26 into 2 basically, or maximum, at maximum they can be 256 characters. So we can say we can have a array of size 256, or we can have a hash map of size 256 in which we can store these characters. Okay, and then so I'll prefer storing these 26. I think I'm supposing this is a these all will be just characters. If this is specified, there's no specify, it does not specify this. Okay, so according to the input we can see that these are just uh, say a small letter characters, which will be 26. So I can have an array of 26, and in those array of 26, what I can do is I can go through all these characters and mark their frequencies. Okay, suppose, let's say in the first case a b c, a b c, b b, I can go to the array of 26. I make an array of 26 size, 0 1 2 3 4 5 6 and so on. So a will be at 0, b will be at 1, c, d, and so now I just need the first three elements, so I can go to a and update the frequency. So a has frequency of 1 2 2, b has a frequency of 4, c has a frequency of 2. Total sums to 4 5 6 7 8 8. Okay. So 1 2 3 4 5 6 7 8. Okay, there are 8 characters and the total number of frequency counts to be 8. Okay, so we can have this array in which we can store the frequencies, so 2 4 2 and so on. But for this array we just need these three elements. This will be having a size of 26 elements. So now 242 is the frequency. Now if I have the frequency, so what I can do is basically, while I am forming the substring, which will be a n square process, so while I'm forming the substring, like I'm including one character in the substring, what I can do is I can decrease its frequency here. Okay, I can decrease its frequency here, or even I can uh, or either, so this is the frequency of these characters. What we can do is we can have an array of 26 size, and this will corresponds to frequencies of the elements that are currently in our subarray. So suppose in the from the above string we have, so we choose a as the initial element, and then we update a frequency of a, which will become 1. Then we go to we second element, we choose b, so we get b, and then we increase the frequency of the second b, so b becomes 1. Now we go to c, we add c, and we increase the frequency of c, which becomes 1. Now we have 1 element of these three elements. Now we again come back to a. So now we go to a, and before when we add, we check what is the frequency of a in this, and it is already 1. So it means we have already found a in our in the frequency, so we cannot take this element, so we have to break. So we can break, and we have the total maximum length. We start in the starting was 0, so now it will be now 3, because this is the length that we have found. Okay, now as we want to check again, so either we would have to, now this is the first substring, this is where we can go at max. Now we would have to start from b. So now we can again, either we could again break this whole break this whole area and start again from b, but we could also do is, we have already counted b and c, so we could just neglect this one and then start from again. So we can have remove this array a, and then we can again go to a, then we can know, okay, so now we, as we remove this a, previously we would have changed its frequency from 0. Now we can we get a, then we can include this a and again mark the frequency of this. So when we see a, then we again get to b, go to b in the same manner. As we check, b is already having one frequency of 1, so we cannot include this b, and now again we have a size of 3, so we do not update this as it's already 3. Now we again uh, remove this b and remove the frequency of this, and then again we have b, so we can update this. So this way I think we can do this. It will have a complexity. First I'll be doing without using this logic of removing the element. We'll just uh, start from the first index, like in the case of a, and then we'll check up to where can we go. Okay, then if we break, as soon as we break for a, then we will check for b. Okay, up to where we can go for b. So that will be still be, and there will be n square, but yeah, we can improve from n cube to n square. So I think that we can code. What my process will look like is basically I create a static or some kind of variable, and then um, that this variable will be maintaining the maximum size, and that we can return. And then we can have a hash map. Now this hash map will be empty initially. What I will be doing is, while I'm creating a substring, so I would have to, in this case I would have to create the hash map or the array of 26 values again and again. Okay, or I can, so, and then I can just go through the list of elements and put, as soon as I find any duplicate element, I can say, okay, that I have found the duplicate, and we can go again. So we could use here, we could use a set, hash map, or even an array. Using a set will be the most easiest. Set and hash map. Using an array will be a little bit tricky, because then I would have to somehow map the character a or b or c to the index, which is not that huge, but yes, we can do that. So let me use an array, just an array. Okay, so let's use this array, simple. So I'll have int maximum equals to 0. This is what I have found, length is the maximum. Now I'll create an array, and array a of size 26, as we have 26 characters. Now I'll make some kind of get index function, which will, if I'll pass the character, it will automatically give me an index. Okay, so now I want to loop through this array for int I equals to this string. So I can create characters, I can create a character of string, so let me do that. And character character array char c equals to s dot to character array to char array, and then I can loop through this array. I is equals to 0, I smaller than th, and then I plus plus, then for int j equals to 0, and now the j will not be 0 because it will be going. So I suppose I is at I, then my j will go from b to the end basically. So next element, so I plus 1, I'll take I plus 1, and j smaller than c dot j length and j plus plus. Okay, so this way we'll be going through the array. Let's put it here now. So now this is the part where we are doing n square work. Now this will give us all the possible substrings, and then we could check in all those substring if there is a duplicacy on that or not. It will actually take an O of n task as well. So we are trying to reducing that O of n task into into O of n by using this array, and for that I think we would need to create this array again and again here so that I can mark this character is so. Okay, now we have chosen the character at ith index. Now I want to map this character c of I in the array ai. Okay, so I want that array of the character at c I. So now c I is a. Suppose if it's a, then I want, if I subtract a from a, then it will give me the, okay, so I will minus the character a, sorry, minus the character a is equals to plus plus basically. Okay, so all the elements of the array will be 0. Okay, and then what I'll do is the character at this a, you can, so the character at ith character basically, which is c of I, which will be a in this case. So a minus a will be 0. This 0 will map to the first element of the array, and suppose if it was b, so b minus a will be 1. Okay, so now this creates a mapping. So I could have a character and then just give it a mapping. I could write a function public to make it easy. Static will be static, not will not be public uh, return a index int uh, index, and I will have a character in that char c. It will just return me the character that I returned this array of it would return me the character c minus a. So now I would have to do just call this function index of c I. I don't know if this solves the problem. This is still looks complex. Okay, is there any other way I can write this? Is simple. Let's leave it this way. I don't think there's another way. Let's use this way only. Let's not use this function unnecessarily. So we have the array a. In the array a, I am mapping with this the first character by I, and then what I can do is now I'll start choosing my sub array. Basically, I need to check if I can include this element in or not. So if my character this, now the length I can also have a length as in again, so int length equals to 0. Now length equals to actually 1, not 0, because we have incremented. I put this character, so let's do the length plus plus. Okay, that will not make len, let's write this len. And plus plus. Now for this element we need to check if the array of I that we have array, and that array if it is already has a frequency there. So the character cj that we are looking at, if that cj array of cj is not equal to 0, if it's not 0, that is it will be non-zero value, then it means that this character is already is included in the array, and then we can just break this loop, and if we break this loop, then we can uh, uh, check if so if we can break, else what we can do is we can have this element in the array. So we just do the same thing here with the j, because we will be including this element in our arrayment. So set, so a of cj now will have a frequency plus plus. Okay, now its frequency is incremented and the length also increases. Now in this case, if we found a duplicacy, we break the loop, and after breaking, what we check is basically the length that we have got. If the length is greater than or max, we will update max equals to length. Okay, and that's it. We will just need to update our length, and next time as for the next loop, if we have the loop, okay, this is the next loop, a and z length will be again initialized, and this will go to the same loop. So let's check if there are any bugs. So s dot to character array, to char array, this I don't think this character array, this is to char array, so this should be correct. We created a c character array. We have a max, this max we are using here. So max, okay, we need to, there's a bug, we need to return it also, no? We need to return the maximum length that we found. Okay, so we have a maximum equals to 0 right now, and then we check, we go to the length of all these characters in the C. Timer started or not? Timer is not started, that is the problem. So we go through all the characters on the length 1, and then we have in the length, and then we have a character setup to have a frequency array. Basically this is a frequency array, and it will check the frequency of the particular substring that we are trying to form. So in the case of ABC, it will having a the frequency of, it will be like that, it will look like this ABC, and again when we go to suppose ABC, and after we get A, it will check this A if it has a frequency of 1 or not. So that we are doing here. We have run 0, we put the ith character, which is in this case first case is A, and then we increment the length as one character is already appended to the list. Then we are actually not forming the substring, we are just having a notion of this with in our array A. Then we are going from j to length, and then checking if the array for this element is present or not, and if it is, then we break the loop, and after breaking we go to the check, okay, whatever length that we have found till now is maximum, is it maximum than the max, greater than the max, then it will update the max. Otherwise if not, then we will include this element in the length and also increase the length. Let's check what is the edge case here. S could be empty, so let's check what if S is empty. There's some compiler bug, let's don't see this and solve this. A, F has a closing bracket, A has a closing bracket, J is also having a closing bracket, then what is the issue? A of C of J, what C of J is? Oh, we have forgot the A, because yes, will be a character, then I need to map this to the index 0. So S could be empty. Now what will be the case if S is empty? So max will be 0, it will not travel to any length, so this for loop will not run, and it will return maximum as 0 only. So it will not, yes, but what if S is null, then this will cause me an array. So we need to check if S is equals to null, then we can return 0. Okay, the answer is correct. Let's look for this, see and the code. So for BBB the answer should be 1, because only one character we can choose for this. Okay, this answer is 1 for this character. We can multiple on this side. I think I can have this, and let's put this. So for this one, we can have pw, then we cannot have w, and ww cannot have. We can have w key e. This is maximum, I think, or key w. So 3 is the maximum for this one. Yes, correct. 3 3. And if we have this again, let's put this. So the answer should be 3 3 1. Is there any other case that we need to handle? S is no, I think that case is handled. But this the most optimal. So here we are doing n square work with O of n memory basically here. Time is O of n square, and space will be O of n, because we are having this array. We can say actually it is constant array, but we cannot say constant. We could say constant because it is 26 array size of 26. So in each time we are creating just 26 arrays, 26 variables kind of. So it's kind of constant also. You can say it's constant, but there's a, I would say that there will be a little bit lag, because you have to create this mapping for each array. So each time you are creating an object, so but it will work. Let's try to submit, and we'll see if there's a better solution. This, what the heck, runtime error for a space. Oh, I didn't expected there would be a space. So will there be more characters? So let's include, okay, can make an array of 26 characters. What does this answer include? So if there's a space, I think we should so I assume that this will be just characters. Okay, so that is not the case. It can have a space. So what was the question is that, okay, it can have space as well. I'm assuming, I think it will just have spaces only, but because of space, now the problem is, if you map space minus a will map to a whole another index. Now the reason why I'm saying this, because we need to check the ASCII code for space. I think it's 32, to where I remember. ASCII of space is 32, then ASCII of a is 60 something. 30, let's see, this is number 32. Okay, let's see the ASCII chart. ASCII chart. It could cause a problem then we might would want to use hash map space 32 is 32 32 31 32. See, space. So ASCII for, so this you can also remember, this space is for ASCII, space is 32, and for smaller a and for capital A, you should remember smaller a, so capital A is 65 decimal, and 65 as so smaller a, and for, okay, 96 96 97, and for small is 97 97 for the smaller a here. Okay, so now I think we could have, so if I have a 256 characters, so the first character that we have, the total number of character here it shows is 127 actually. 127 to 128, you can say 0 to 128. 0 to 128 are the ranges of visible characters. Then you can have these characters as well, which are not which are extended ASCII basically. So you can have a range of 10 to 128 for the ASCII, normal ASCII, you can say normal, and extended you can say from 128 to 255, 255, yes, this 255. So 255 total, 250, there are total 256 characters, so 0 to 255 total. So basically 256 characters. 0 to 128 are like normal ASCIIs which are visible basically, and visible are these, but there are some of them which are not actually, and these are special, so we can say extended. So 120 to 8 to 255 is extended. So this, we are sure that this will be the actually uh, visible range. So this will at max this is what they can give us. So we can have uh, each character mapped to their index by this 128 character length. Now to do that, what I would need to do is null is the character is starting at 0, so I think we would need to do as the character for this the space 0th character. We should remember that 0 is for null, which is we can write command /0, that is null. Okay, so let's try this. I think this would work. So here if I have, so then I would need to have a character size of 128, because 0 to 127 128, no, 127 actually, this should be 127. Yes, 0 to 127, not 128. So 0 to 127 will pick 127. Okay, 0 to 127, total 128. Yes, so I will have a character of 128 size. Then now instead of mapping to a, we can map to null. Okay, and then here also I think this should work. Let's check if it will. This will also be changed 0. CJ minus 0. So this is the null character as we're supposed to. So 331 and this 331. Yes, okay, that works. So for this we'll have 128. So I can now it's now still also it's constant, because at max we are using 128 characters at any point. So let's submit. Oh shit, I should have checked with my space. Shit, I should have. Let's check with space. Okay, it worked. So this, let's say, where is our solution? It's 12 milliseconds. So yeah, sometimes it's not very. So our solution beats 29% of them. Okay, I think we could do better, but we cannot. We should not take it always seriously, because there are some cases where it could, just because the resources that Leetcode did not provide us or any judge. Okay, so this is our solution. Now there is, this is n square, so I think we could actually do it in O of n if we use the logic that we were previously discussing. That, so in case, because we are doing this n square because we are doing some redundant work. So if you see, so what's the redundant work? Let me show you. So the redundant work that we are doing here is the question description. It is not clickable. Why, like, no. Okay, so the reason I'm saying it's not why we are doing a duplicate work is, see if this, let's remove this and say ABC. I will comment on it later. So here we see ABC, ABC, BB. So if you see, when you get A, so ABC, ABC, BB. Now you choose the first character A, okay, then you choose the second character as B, then you choose C as the second character, because these are all unique. Then now you choose A and you see, okay, we cannot choose A because we already had A before. Okay, so you get A, B, C, and then you get A, B, C, and then you get again A, so you cannot choose A. You have, okay, so now this is the maximum we got. Now we can remove this A, okay, and then we can again proceed. We will not have to again do operation for these two again, B, C, because what is happening in this case, I go for, in the first loop I start with A, okay, then I go A, I include A, and then I go for B, and then I go for C. After C, I again go for A, and in A it will crash here. So it says, okay, you got A, you got B, you got C, and now for A you are again including A, you cannot include A. So you check the length and return. Now this outer loop will again start from B. So we'll have include B, then you check for C, then you check for A. So here B and C are we are doing redundant operations. So what you can do is basically somehow A exclude this A at that point of time, and then proceed with the execution. So now if you get C, so after C you got now A. Now this A you can include because you have decreased the frequency of the earlier A. Okay, so let's change this code a little bit, or let's we can change this code a little bit, or can have write this. So I think this inner loop will have to be removed. So no, this loop will be there, but then the thing is, okay, let's write it again. I will not, either I will get confused. Okay, so we have the corner case. Okay, then we are creating into a string, a character array. We have a maximum array of size. Now what we want to do is, first we have this array. Now we include the first character A. Okay, then we go and we include the second character, cool. Then we go and include the third character. Then we check, okay, this character is already in the included one, so we somehow know that this is the stop. Okay, and then we pause here and check what our length is. Okay, then we have again we decrement the previous A, so we decrement our length and as well as the frequency of this element, and then we again continue with this array. Okay, so let's okay then, so will it fail anytime? So for B, I don't think it's failing because we have included first B, then we check second B is already there, we cannot this, we can exclude this B, then include this B again, so I don't think it will fail here. And the case of PWTCK, let's check this case. So we include P, then we include W, then we again check W, so W will not, we cannot include W. For that we will have to decrement its frequencies, the previous W's frequency, and also decrease the length, then we can include this W. But the major point is, when we reach this third W, we know that this 2 has to be saved. Okay, so let's create a integer array of size A is equals to new integer of size 127 128 actually. Now the best it's actually better to always create a 127 size of array. I would say always better to create these you can also write this. So it's always better to create an array of size 128 rather than having a 26 or suppose 10 if you are dealing with some numbers. So rather than having a size of 10, because then we wouldn't need to remember all these variables where A belongs or not. And also it might be if you even you somehow missed the question, some part of the question, or so you would not have to assume. So it will be a safe side to have an array of 128, and then for finding the index you can just subtract the subtract the character and the null character from the character basically. Okay, so let's create an array. Then now I need to loop through this array for int I equals to 0, I smaller than c dot le ngth I plus plus. Okay, now we need to, the character that we currently are at, we need to just put this character. Okay, so here we will not be able, we need to check what is the So all these arrays 126 elements are now are null. Okay, so the first character that becomes is a, so we can check a if the a is present and already present in this or not. Okay, so we would also need a length, so I think length we can have length here and lay e and length. Length equals to 0. Okay, length is also equals to 0. Okay, then so we can check if the array A, which is the basically frequency, has the character that we are looking on our character array C of I, and minus the index, basically to get the index of this array we include this null. Or to better understanding, what you can do is int char ch equals to the character C of I. You got the character now. Instead of this having this array, you can have ch minus the 0. Okay, it will be just a bit much better, much clear. So now you check if the array of this index is not equal to 0. If this is not equal to 0, then means you cannot do further operation. Else if it was 0, that you can basically include this array. So what you can do is then you can just have this frequency of this array increment by 1. So array of ch minus the null the null character plus and also the length plus. So if it's not equal to 0, that means this character is already present. If it is not present, that means you can have this character in your current sub array. So then you can add the length, increase the length, and also the frequency of that character. Now, but if you have this character, then this is the position where it means that position where it means that the current substring ends. So now what you will do is, in the current substring you are looking at will end. Okay, now the this ends because of what? Because of one of the CHRA character is similar to this character. So what you can do is, now you can remove that character. You can remove that character and decrement the length as well. Okay, because now this is this was the state ABC. So in the case of in the uppercase, this was the array. We got A, we got B, then we got C as well. Now in the case of A, we reach A, we go into this. Okay, now we know that ABC was the maximum that we could get. It's kind of greedy. Okay, and we cannot have A. So what we'll do is remove A, because A was the element which because of which we got the this point. So what we'll do is frequency of character ch. This is the character that we have already seen. So we will do this. Okay, the character frequency of this character, we can remove this character ch and this minus. Now this removes the frequency of this character. Okay, and then we also decrement the length plus length minus. Okay, now this way we deleted that character from the current list. So now in the case of ABC, we have we did not pick the last A and we remove this A. Okay, so we have, but before doing that we need to check if this was the actual is the required substring. Okay, so before doing and decrementing this, what we need, because we found a b c was the we could choose, so we could not choose a, we could choose a b c. So is that was the, if that was the real answer or not. So for that we just check the length. If our length at this point, length is greater than max, then we would have incremented max to length. Okay, if that's not the case, then we know that the substring that we found, which we had already found a better substring before that, so we could just remove the character that we had, this which we had already found, and decrement the length. Now if you say this operation will be redundant, because now you removed this a from the list. Okay, let's take this example, not let's take this example for better understanding. So pww, now you reach p and w. Okay, then you again reach w, so you check, okay, w is already present in this. Now you reach in this, okay, w is already present, so pw was the maximum that you could get. So pw, you check, okay, pw length is 2 and the maximum for now was 0, because this was the first substring that you can get. So you'll update the maximum to 2. Okay, now this is updated. Now you will increment, you want to add this w basically to the uh, uh, substring. Okay, okay, then that is one issue, because if you, so means you deleted this w basically. Okay, this w is deleted now. Here this w is deleted now, so you have p, then you have w here, you get this w, but then it's no longer a it's no longer a substring. Then you go to k is valid, then you go to e, then you again go to w, so you choose this w. Okay, I think this we got we reached a lot of this, but there's an issue, because if we cannot, as soon as we find, suppose we found this w, okay, that means we cannot start with this w or this p. Basically we could start with this w, but this w will have contribute just one substring, so it could cause a problem. So if I just skip this, let me just check. If I just skip this, because adding and deleting the array will have the same effect if I just don't add this, so it will just have a same length. And then if I run the code, I think this is wrong, this is really wrong. And if I had to return also, return the maximum max, okay, but this will be wrong, I'm sure this is wrong. So what is the algorithm that you can use? So we had an see, wrong answer, 34310, which is 3311. It's wrong, it'll be wrong. Okay, let's choose the lists, the related topic is their hash tables, 2 pointers. Okay, we did not try 2 pointers. Sliding window, oh, shit. Okay, so the approach we are trying is not correct, but relevant point shows that it is sliding window pointer question. Okay, so let's check. 2 pointer. How could we do this in 2 pointer? A, B, C. So this is all. I don't think this will work. So let's delete all this. Let's delete all this. Okay, so if I have 2 pointers A, B, C. Okay, sliding window. This is what I was trying to do. Sliding window is what I was also trying to do, because ABC, then in this case of, if you have a sliding window first ABC, 3 window size 3, then you cannot have A, so you move this side BCA, then you cannot have B, so you have CAB. So it was kind of sliding window that I was also trying, but the issue it causes is suppose suppose if this example this does not work with sliding window, because you have PW, two sides of sliding window, you cannot have third three. Then you again have WW, which is also not valid, you'll have one element only. WK is valid. mm. छोड़ देते हैं 10 मिनट Okay, so let's look at some solutions. Let's see if we can see brute force. Oh, there's a 2-3 methods to all this. To approach, second approach, and third approach. Sliding and optimized ASCII Java, assuming ASCII 128. Okay, there is we correct. We are also assuming 128. So let's look at the solutions. The first solution they are saying is okay, just okay, this will. So approach one is a brute force approach. First is check all the substrings one by one and see if it has no duplicate characters. So this is one approach. It will have a time complexity of n cube. Yes, correct, n cube, because what they are doing is here, see, length of substring, so all unique. So basically they are doing first two for loops, which is basically calculating getting all the substrings from the index I to that index j. So this I to j, and s is the character. So basically then it will check if all unique will basically go through all the elements from these I to j, which is basically start to end, and then check if any character is repeated or not. And then if it is, then if it's not, basically if all unique, then the answer, basically they have created this answer will be math.maximum of answer. And I should actually use math.maximum, that is also I need to use here. It's better to use math.maximum than again having if loop again and again. Use math.maximum rather than if loops. Okay, so for the maximum of the answer and the length basically here, j-1. So this is of n cube algorithm, and space will be a constant space. Space will be constant. Yes, where is the constant space? To verify the characters within index range ij, j is our exclusive, are all unique, so we need to scan all of them. Thus it costs this, and then for the given I, the sum of the time costed by each is this. So this is formulas, we don't need that. Simple as this. Of n cube is the complexity. Space complexity is we need k space for checking a substring has no duplicate characters with k is the size of the set. Okay, they're using some kind of set, I think. Yes, they are using some kind of set. Basically anytime the set contains this ch, true becomes true, then we return false, because set already contains a value. Then we have a sliding window. Second approach is a sliding window. So sliding window approaches, they are doing it in complex city of 1. So they are also maintaining a set. I told you that having a set is much easier than an array, but we again thought of using an array as challenging us, and that's how we found that using 128 will be a better choice rather than using a 26 character array. So the naive approach is very straightforward, but it is too slow. What is the complexity of this column? This is fan. How is that slow? It's way better. then 1 cube. So the naive approach is very straightforward, but it is too slow. So how can we optimize it now? So this was the naive approach. Okay. In the naive case, we repeatedly check substring to see if it has duplicate characters, but is unnecessary if substring has ij from index I to j minus 1 is already checked to have no duplicate characters. Okay, we only need to check sj is already in the substring sij. Makes sense. So basically we have found that sij, if we know that from a substring from index I to j minus 1 has no duplicates, then for the including the next element, suppose as j is the next element, now for the including if we include that element, we don't have to change, we should not have to check all the I to I j minus 1 elements for uniqueness. We just check the last element if that is the unique element or not, if this is the element present in the Sij or not. So to check if the character is already in the substring, we can scan the substring, which leads to O of n square algorithm, but we can do better. Check if the character is already in the substring. We can scan the substring. Okay, it leads to O of n square. Yes. So by using a hash set as a sliding window, checking if character is in the current scan can be done in move 1. Correct. Uh, so sliding window is an abstract concept commonly used in arrays and strings. So this is also possible as strings. So you can write this as that sliding window is an as concept used in this only. You cannot use that in VST and all stuff. So you can say sliding window is concept used commonly in arrays and string manipulation, string problems only. Okay, so a window is a range of elements in the array which usually defines by the start and the end characteristics. Okay, makes sense. So we have I and j, that is I and j. So left closed and right open, so we are not including the right element. The sliding window is a window which slides its two boundaries to certain directions. For example, if we slide ij to the right one element, so it will become I plus 1 and j plus 1, where this is exclusive. So left is closed and right is open. Now back to a problem, we use hash set to store the characters in the current window I and j is equals to I initially. Okay, so the window is of size 0 or 1, we can say 1. So then we slide the index j, which is this one, the next one, the right one basically, to the right, and if it is not in the hash set, we slide j further. Yes, okay, and doing so until sj is already in the hash set, and as soon as we have sj in the set, we found the maximum size of the substring without duplicate characters starting with I. Correct. Then if we do this for I, all I, we get your answer. So okay, so let's understand this code. We are having a hash set, we have answer I and j. We are going from I smaller than n and j is also smaller than n. Okay, we are extending the range, so basically I and j are at 0, so they're pointing to first elements, so they're in range, only one element is in that. So if the set does not contain the character at j, the next character basically, uh, as dot character at j, then we can add this character to our set, and we can increment as well, and the answer, because this is a valid substring, so we can check what is the maximum, which is maximum of answer and the length. Okay, but if we found this element, so then we can remove this element and increment I plus plus. So basically we are having this I and j window. Initially I and j is at 0. What we are doing then, okay, we check the element at j, which is the right side, is in our set or not, it can be on our set or not. So we put this array, then we can check the element in the second set that can be in our set or not. So in this case, so we check, let's say this, so a can be in our set or not. Yes, a can be, so we include it in set. Then we can we increment the j, so now j goes to b. Now if b can be in our set or not, b can be in our set because it's not duplicate, then we check c can be in our set or not. We can say c is in our set. At each point we are including this. So a, when I include a is the maximum that we could get, so the maximum length is 1. Then a and b, a and b was the maximum, so the length became 2. Now a and b and c, so 3 is the maximum, so 3 length becomes 3. Now we go to a. Now to check a can be in our set or not, so we can say okay, a cannot be in our set. So if a cannot be in our set, what we do is we basically increment from this side. So we first delete the previous a, okay, the ith a, and we increment a, okay. Now in this case we did this, okay, this is the case that we are doing. So we remove the character from that, okay, and we increment the I. So we removed a and we increment I to basically now our I is at b. So we can say b, where here we're starting from b, we had c, we had a. Now we check b, so b cannot be included. For that we need to delete this b. So now we are at c, and then we are at b, include b. Same we can do for c. For c we can, for including c, we need to delete this c, we delete this c, and we are now at starting at b, and we can have c. Then we have b. So now this is interesting. Now if we have b, now b is already in the set, okay. Then to include this b, we will need to remove this b, okay. Then we remove the character at I plus plus. No, we do not remove b actually here. That is the main thing. We are not removing b, we are removing the first character I plus plus. So we remove a, okay. Then we again check. Now we are at index b. Then now we check if we can include b or not here. So we cannot actually have b because b is already in there. So now we again delete the first character. So now we are at c. Then now we can have b or not. Yes, we can have. Then okay, then again we are at b. So can we have b or not? We cannot, because b is already at the index. So we do not include it, and first we delete the first character. So now c is deleted. Now the set starts with b, index b. Now can we have b or not? Now still we cannot have b because b already starts. So now we delete this index. Now we starts at this b. So can we have b or not? We can have b here. So we can have b. So this is the index. So in all this process, the maximum size would be I said maximum was element of size 3. So this will work with this as well, because so that was the question earlier. What we were facing issue was, if we deleted the wth in this case as position, then we this does not become a substring, because it becomes a sub sequence as we have script character. So the solution was basically to remove, before removing this p, we do w. Before removing this w, we would have to first remove this p, and then we would have to remove this w, and then we can have k and e further. Okay, this is our approach we are getting. Now there's a way they are saying that they can improve on this as well. Okay, let's first just implement this logic. So this is the sliding window logic. Sliding the window. Okay, so let's remove all this. Let's just write the whole code again. So the first thing is just handling the null pointer. So if s is equals to null, we can return 0 length, right? And if not, then okay. So now we have to create a sliding window. So a window basically. So for index window, I am having a I which will be 0, and let's I have a I and j, and both I equals to j equals to 0. Both are initialized to 0. Okay, and we will also have a maximum that will be int maximum that we can get. Okay, now we have a sliding window. For the window we have this, and maximum, for the maximum we have this. And now for maintaining the what do you call the having like constant time for lookup, we can use set, but let's not copy the solution. We'll implement the lookup time in array using array. So let's do integer character array. We can have a character array of character. We can okay, I'll have a character array so that I can use this. I'll have int c equals to new int sorry char c. Should better to create this kind of array. C is equals to new. This is Java style array. So as dot to char array. Okay, then I'm having another array just for my lookup, which is int a equals to new integer of size 128 characters. Okay, 128 ch 128 characters starting from the null character with ASCII 0. Okay, so for let's now browse for int I. Should I have I, because I is what we are. Okay, for int I equals to 0, I smaller than, should you have I. Now I want, should I have this for loop or while loop? We can have, so the idea is basically we will go tell our window can go, which is I should be smaller than the length of the array, and our j should also be smaller than the length of the array, and I should always be smaller than j as well, because that's a window. We cannot go I, so I should be, let's do a while loop only. Otherwise, if we use for loop, then we would need to have checks inside that. So for okay, while we have I small than let's make it's easy to have, and r equals to c dot length. Let's not have this. I smaller than c dot length length, and j smaller than c dot length, and I should be smaller than or equal to c j. Basically, you cannot have the windows I can be greater than j, so I will be at the left and j will be on the right. So this is okay. Now initially I and j are at the same line, so basically they are pointing here a, but we have not included anything in the set. So if we first include this element, the element that it is pointing to in the set or in the basically frequency array. So now we check if we can basically include this array or not. So if the array a of, let's take the character better, ch char c h equals to c of I. Okay, this is the character that we are at, and no, j is the character that we are trying to include in our character. We are checking basically to put in our substring. Okay, so character at j, both basically they are at the same, but in the future j will be what, j is what will be incrementing, and checking if j, the character at j can be included in the substring or not. Okay, else so the character that at ch, the frequency, we check the frequency, ch minus the null character 0. So if array of ch minus 0 is not equal to 0, basically if it's not equal to 0, that means it has already appeared, appeared in the substring. So if it's already paired, and if it's not, okay, if this is 0, if it's not, then we can include this. Not appeared, include the CHRICT. Now what including means, basically that we increment this array. So we do the increment of this plus plus, this means that that's incremented, and we also increment, there's also a length that we can have, as well as length is incrementing at each point. So let's also take integer n equals to 0. Okay, so now we check for this character if its character is included or not, it can be included or not. So here it cannot be included, here it can be included, so we increment this the frequency of that character in the substring, and also increment the length plus plus. Now this character can be included, so it's a valid substring at this point of time. So okay, it's a valid substring at this point, so we should check if it's our answer or not. Okay, so we should check the maximum is equal to basically math.maximum of max comma at the end length, and who's the maximum. So now this case does that, it puts the array element plus. Now also the thing is, we can have j plus plus, basically we have j plus plus. Check if we can extend our window, not check this, basically extend our window towards our right, basically. Okay, so in this case we are extending our windows towards right. Okay, now in this case we could not pick this character, in this case we could not take this character. So suppose in its initial case it will not be the case. Initially for the first character this will always be executed, but for the suppose second character, if we had suppose this w comma w, so in this case the first character will be included in the array, and we will have our jth window to increment this side. So now we will have at this point, and at this point now we cannot have this w because it already exists. So what we'll do is, basically we will delete the first w and then start with this w. Okay, so we will basically like extend the ith, like in the left side of the window, extend the left side of the window towards the right, basically. So initially the window was this w, and both w were in this range. Now only the second w will be in the range, and the first w will not be. Okay, so here we do as, where's my cursor? Where is this? So we do I plus plus, because this is, we don't want to include this cursor, but we would actually want to delete this character. That means the character, this a and this thing, we will have to remove it from the from this frequency, and the length is also decreased. And now you could say that this is also a substring, because we have removed the first character and only this one character. So it could happen because it is also valid, so it could happen that this is also valid, and you can have a check here, math.maximum this, and then you basically extend the left side of window towards the right, extend the window, extend the left side of the window towards right, extend the right side of window towards right, basically. basically here we are shrinking the window, kind of shrinking the double, and here we are expanding the double and the window, and finally we will return the max, so we can execute our code. Let's run. Max equals to 0. Okay, now so this is accepted ABC. Let's check for all the test cases. You could have your own. So one test case is which it fails is the space one, which it will not, because we have used 128 as the size of the array. Let's read the description. BBB, and then we have this. It's a good question, I would say. So our output is 3114, and the actual output is 3113. So we are failing for this one, PW WKEW. And why is that? Let's do a dry run. Okay. So PWWKEW. So we get to the first character here. Let's do dry run together. Console. Okay, so we reach PW. So let's make a window. In the window, there's nothing in the window window. So we have this array. Now we check I is the length of our C dot length is 1 2 3 4 5 6 6. 6 is the length. I is at 0. Okay, and J is also at 0, and I should be smaller than or equal to J, which is correct. Now the character at CH is equals to we have P. In the case of PWWKE, then we check if the array have this character P present in this the frequency of P basically, which is, if it's not 0, it will be 0 basically because there is no. So we go into this and we mark the frequency of P in the array as 1. Okay, and then we increment the length. So now length equals to 1, and okay, length is equals to 1, and then check what is the maximum. So maximum is equals to length maximum of the maximum and length, which is max is 0, so max becomes 0 basically. Max becomes 1, sorry. Okay, then we increment J++. So now with J++, now the window slides and has P in it, and now we are checking for the W. P is already in the window now, and we are checking for W to be in the window not. So we check for W. W is frequency of W will be 0, so W is not in the substring right now. So we'll check into this, and we will increase the frequency of W. So now W is at a frequency of 1. Okay, CH minus null, which is the character A at W plus plus, and then the length plus plus. So now length becomes 2, right? Yes, length becomes 2, and now this is a valid substring. So we check math dot maximum of length and max. So now 1 comma 2, it becomes max becomes 2, correct. Now we again increment J. So now PW is in the subset, and now we check for the next W. Now in this W we check that we found that it was already in the index. Okay, so what we do is we first decrease. Okay, this is where we are doing, I think, wrong, because we are removing the character W, which is wrong. I already said we don't want to remove the character W, we would want to remove the first character basically. Okay, not the character at CHI. We would want to remove the character which was earlier in the array, which was the character which was at I. Okay, so this is wrong, because we would, so in case of PW is already in the PW is already in the slide, okay, window. So we want to remove the first, we want to remove then P, then we would want to remove W, and then we can continue with W. So first element of the array we want to remove. So now we want to get the uh, um, frequency of the first element. So what is the first element is P. How can I get the frequency of the first element is by the array I. So I is at C at I. So basically now the character CH is not this basically. So we found this character, remove the first such array, say character of the CBS data substring, and move the left hand of window to the right, because now this was the, because this was on the left hand of the window, no? So let's remove A rather than CH. It would be char left character equals to A of CH, A of, sorry, A of I, oh sorry, C of I. You can also name this CH to be right char. Now this right char can this remove this, and then this character will be here. Right character, copy this right character and also paste this here. Okay. So this right character minus this. Now the left character is will be at C of I, and then we want to remove this left character, and the length should be decreased by -1, and then it is a valid, because this was not valid, because now you are removing a character from the middle of the substring, which is not valid. You can only remove a character from the ends of the substring, then only it will become a substring. So let's now run. Yes, 313 3113, correct. Now let's submit. So this is of n algorithm. Yes, it solves the problem, correct. We can say of n time of n space of spaces, you can say 128 constant, static constant, nearly constant, because only 128 variables, kind of, you can say. Okay, now this is the way we implemented it, which is actually very robust. So I think you would use, instead of using array, if we used set, it will become more easier. Instead array, let's use sets. Okay, so let's remove this array here, and let's again write the whole logic. Let's encourage to write the whole logic. Okay, so we need the character array, correct. We need max, we need length, we need ing for the window. We also need a hash set of, now this set we will be having characters. We can just write directly have characters in them. Characters character set equals to new hash set. Now for this hash set, what we need to do is again loop through this array. Now while our I is smaller than Let's do length n equals to c dot len gth. I is smaller than n and j is smaller than n, and I should be smaller than or equal to j only. Okay, now the character that we have is the last character, you can say. So char last char equals to the character will be c of j. Yes, now this is the last character that we would want to, last character or end character, basically end character and such character. Now we check this if our set dot contains, so DINS contains this end character, if it is the case, and else if it does not. See, so if it contains the character, that means we need to decrease our size, which is shrink our, that means we need to shrink our window from the left by removing the leftist element first. Okay, again this is the word. But suppose if it does not contain, then what it means that we need to just add that to the set dot add this and character. Okay, and then it will also increase our length. So length, now the length becomes, and we can have length plus plus. We are using length, but we would also not just by using I and j we could do that, but I prefer just using length. But then you need to remember, just if you are increment, then you also have to decrement. Now you have incremented the length, you have added this element to the set. Now you widen the window. So j plus plus is shift, not shift, widen the window towards the array. Now why we are doing this, because now when we increment j plus plus, now the whole window remains the same. It's just we are adding one more element to the window that we have. Okay, and then now the thing is, basically you need to check, now you have added this element to the set. Okay, now if this is a valid, new element is added to the set, new element is added to the set, to the substring, basically check. So not check, you already have checked. Now your substring is already to the, so now check if it is the maximum that maximum that we are looking for. So for that we just need to calculate the max, which is equals nothing, just math dot maximum of our length comma the maximum. Okay, that's it. Now if that already contains, what does it mean? It means we need to first decrease our window. Now decreasing our window will be, we need to remove the leftist element to decrease our window. Okay, the leftist element. So now the leftist element is basically at the leftist element is present at ith index, as our window is basically from I to j. This is our window I to j. Okay, j is not inclusive. Yes, so you can say this. So you're going to calculate leftist or the start character, strt character. Start character is the starting character of the substring, and this character will be just nothing but c of I. Say strt starting such a character of the substring from I to j to j. Okay, now this character, so we need to remove this character from the subset, so from the set, the set dot remove. This is start char. Okay, now start character remove हो गया, and that is an O1 operation because of hashing. Now we have removed the character. Now we need to also decrement the length minus minus. Okay, now we have decremented the length as well. Now at this point of time, it is also a valid substring. Okay, now already we have included, it will not make more sense, like we have already found an array, a substring of this length, but we can, for the format uniformity, we can have this. This is also a valid substring. So check if this is the answer. So check if this is the answer. Which most probably it will not be, because we have already found we are decreasing the basically element, so we would have already found a maximum element, which it will not always, which it always will not be, always will not be, but just for uniformity, as we are the CRES and decreasing the length, so we already have noted down the maximum length. So you could just say I minus minus and will work, but we can have max is equals to math dot maximum of max comma array. The more important is this, basically you need to decrease this size. So now let's run. This code is a much cleaner code. So there's an hash set, new hash set of, okay, where's the array? Let's not look this hash. Okay, spelling mistake, typical. Hash set. Oh shit, I forgot to return this. Return the maximum element that we got. So do that. Okay, why is this is corresponding to this array? This is corresponding to this. So I would have to do this. Man, what is going on? Character array start character C of I. C is a character array. What is the issue? Let's just say S is, yeah, this is correct. These all are correct because there's no comparison in that. I and J and I is more than J. Character is C is more than J, then I C is more than I. What is the issue here? Char equals to this start character, and that equals to C of I, which is really similar to this. Then what is the issue in this? Let's say this is array index out of bound exception. Okay, I is smaller than n, j is smaller than 1 also. How is that index out of bound? What are you testing for? Let's do this case A, B, C. Let's only do this case. This one is that you're getting this from this as well. index -1 out of bound for length 8. So there's a lot of huge index out of bound index. We are doing array shit. Instead of I minus minus, we had to do I plus plus, man, because we are incrementing that. Nah? Cool. That was the issue. How would you get a of -1 is correct? Let's test all the other cases as well. Let's run this test case. This is a good question for sliding window. Yes, is correct. So let's submit that. The time complexity of n and constant time. So yes, it is submit. And this, if we compare, this and this solution, so these are 72%, and this was 99% actually. Okay, my array solution was actually better. Cool. Now we can proceed towards the more optimized solution that they are giving. Sliding window is the approach we followed. This is the solution. They have more cleaner code than I have, but that's okay. And they are just removing this element, and so we are doing this first character. 1 second. Okay, they're removing. Okay, they're getting the character from this only. Character I and plus plus. I could have done that as well. That's not a big issue. Plus plus. Okay, thanks. Same thing. It's the same thing. It's just the code is way more cleaner than I have. Now the time complexity is 2n. The reason why it's 2n is okay. So you can read this solution. I'll read this later, and let's make the solution end here. Thank you guys.